Alright.
Okay guys, we're into friction and we've been talking about the basics of it, and today we're going to look at a kind of a classic problem that deals with pushing on a box, seeing if the box will move, and then if it will move, seeing how fast it will accelerate. And guys, what we're going to do is we're going to look at pushing on it and see if it exceeds the maximum static friction force, and if it does, then we'll know it's going to move. Once we do know it's going to move, then we'll look at it, the kinetic friction force, and work from there. So the main question is, will the object move when the force is applied? And the second question, if so, determine the acceleration. So here's our setup. We have a 20 Newton force acting on a 10 kilogram box that has a coefficient of static friction between it and the table of 0.2, and then a coefficient of kinetic friction between it and the table of 0.1. So guys, if we look at a free body diagram right over here, we have the weight of the object pulling down, and then the table's got to push up with a normal force that's equal and opposite, because of Newton's third law, right there, of 98 newtons. And then guys, we have 20 newtons pushing on the box. It could be pulling on the box, either way would work. And then the thing that's going to oppose that pull is going to be the force of static friction max. So we got to go about determining what that is. So if we do that, the formula that we've learned already is coefficient of static friction times the normal force. Since we're on a horizontal surface, it's really easy. The normal force is equal to the weight, which we already determined. So we come up with a force of static friction max of 19.6 newtons. Pretty close to 20, but because it is not as great as 20, the 20 newtons is going to exceed the force of static friction max, and therefore our object's going to begin to slide. Now, once it starts sliding, we move from static friction to kinetic friction, and like we talked about in class a couple times, the coefficient of kinetic friction is always going to be less because you break over on those little particles, and once the molecular interfaces, and once they start sliding, it slides easier. We've all done that with like a safe or a table or something where you push and it's hard to get going, but once you get it going, you can roll it along because it's under that kinetic friction. So let's look over here. We'll move over here. The force of kinetic friction is going to be equal to the coefficient of kinetic friction times normal force. So we throw our 0.1 that we talked about before in with our normal force of 98. Gives us a kinetic friction force of 9.8. When we sum those forces, guys, when we're sliding, the sum of the forces sliding, we got our 20 Newton force pushing that direction. We got our kinetic friction force pulling backwards. We're going to subtract that, get a net force of 10.2 newtons. And guys, with that plugged into Newton's second law, force equals ma, we can see that force of 10.2 newtons on the 10 kilogram mass is going to yield, divided by 10, 1.02 meters per second squared acceleration in the direction of the net force. And guys, if we look at the direction of the net force, it's 20 newtons is pushing that way, 9.8 newtons is pushing back that way. It probably would be prudent to throw in a vector indicator right there, and then we know that since that's a vector quantity, it's pointing in that direction, our acceleration is going to happen in the same direction. So we come up with the fact that the box will move because the force applied to it exceeds the force of static friction max, and then once we figure out the net force when it's moving and sliding, then it comes out to be an acceleration of 1.02 meters per second squared. So that's friction on a surface when we push with a horizontal force. The next lecture we'll look at is going to be pushing with an angled force either down or upward, which will affect the normal force, but we'll look at that when we get there. All right, next.